Here's one potential answer to the exercise that we performed in class today. First, let's identify which loci are starting in the X chromosome on the left side and are absent in the ultimate chromosome that we're trying to produce, in this case represented by the Y chromosome. Let's see, we're missing loci 2, 4, and 5. All the rest are present. So all of these have been deleted, which we annotate as a triangle or delta for deletion. So let's start by deleting loci 2 and 4 and 5 from this chromosome. And as we discussed in class, these sorts of chromosomal arrangements, like deletions, don't necessarily happen at the same time, but for the ease of taking up less space drawing this out, I'll assume that both of these deletions happen at the same time. So that eliminates locus 2 and loci 4 and 5 from the intermediate chromosome we'll call XB arbitrarily, which will now have loci 1, then 2 has been deleted, so we'll have 3, 4, and 5 have been deleted, and then 6, 7, and 8, and 9. Now when we compare where we're at currently and the ultimate goal, the next thing that I notice, although this is not necessarily the only way to solve this problem, is that ultimately the 3 and the 9 need to be together. So that might suggest, for example, that you take this block of DNA and invert it, turn it upside down. So that might create chromosome X version C, let's say, where the order of markers will be 1, and then we reach the newly inverted block 8, 7, 6, 3, with 9 on the end. So now the 3 and the 9 are in the appropriate place, and we need to get the 8 down next to the 3. So that suggests another inversion, producing intermediate chromosome XD with an order 1, 6, 7, 8, 3, 9, and we're almost there. Now the 6 and the 7 just need to be in the opposite orientation, so if we have one more inversion, that will yield 1, 7, 6, 8, 3, 9, the final order. In sum, it looks like it requires 2 deletions, 2 deltas, or triangles, and 3 inversions, minimum, to go from the X chromosome on the left to the Y chromosome order of loci shown on the right. And I have 2 follow-up questions that I'd like you to think about. The first is, did you find a way that involves fewer steps? Was there a way for you to go from the X chromosome on the left to the Y chromosome on the right requiring fewer than 5 chromosomal rearrangements? The second question, which is more interesting, I think, is, did these changes necessarily have to occur in this order? That's something that you should play with. Remember, this is one of those exercises that does not necessarily have one correct answer, so the order of inversions and deletions that you used might significantly differ from the ones that I just drew. That does not mean that you and your process or your scheme is wrong. It's just different.